All right, welcome back. We are still on the circle geometry. In our previous video, we talked about one of the theorems of circle. So we are going to proceed. We are going to continue from where we ended today. We are looking at the theorem 2. As we stated in our previous videos, I gave you eight different principles or eight different theorems that we shall be looking at. So we shall take them one after the other and see how best we can go through all of them. Without wasting much time, let's quickly try and see how or what this theorem also states. So in theorem 2, we are saying that that is angles in a semicircle, angles in a semicircle. So when we say angles in a semicircle, what does this theorem say? This theorem says that it describes an inscribed angle that is across a diameter will always be equal to 90 degrees. Or it also says the angle subtended by the diameter at the circumference is a right angle. Yes, that is equal to 90 degrees. Okay, so we all know what a semicircle is. In the previous lesson, we looked at the various parts of a circle. We're able to identify what a semicircle is. So this one I will not waste much time on that. Now let's take our circle. Let's look at um, our circle and identify all these parts so that we can look at what this theorem is saying. Okay, so let's take this as our circle. Then we identify the center. Okay, then the diameter, as we are saying that the diameter divides the circle into two equal parts. So let me remind you again, when we talk of the diameter, we are saying that it's a line segment drawn from one point at the circumference of a circle through the center to another point at the circumference of the circle. Yes, and that lines. And we are also saying that it's a special name given to what? A chord. Yeah, so a diameter is also a chord. Okay, but just that it divides the circle into two equal parts and makes the two halves what semicircle. So that is what our diameter, that's the line. Good. So once we have this one, then we can draw one chord from one point to another point, and then we draw another one. Once the two chords meet at a point, the vectors there, that angle from there is what we are talking about. And we are saying that it gives what? A right angle triangle. Okay, so that angle there is subtended by the diameter. Okay, so whatever you have a circle, okay, and you have a diameter, okay, if you have two chords that meet, if that angle from there is subtended by that diameter, then it's going to give you a right angle. In that case, 90 degrees. Okay, yes. So let's give them a labeling. Let's give the center as O and the rest as A, B, and C. Let's try and um, draw a different shape, because there are times that you get a different shape. You may not see it like this in the question. So we are saying that angle ACB is equal to 90 degrees. Okay, yes. So let's look at this diagram as well. So we have another circle, then our center, and then we have this. Good. So it can also get this shape, and then we get another one here like this. Yes. So once you don't see it as the first one and you see it this way, once you realize that that angle from at the circumference of the circle is extended by the diameter, then that angle is what? 90 degrees. That's what we are talking about. If that is the case, we are going to use our software. Remember in our previous lesson, I gave you a software that we shall be using for this. We are going to use to determine, to prove that indeed an angle subtended by a diameter at the circumference is always 90 degrees or right angle. Okay, so if that's the case, then let's quickly move to our yes, let's move to our software. All right, so this is our software. Okay, that is the GeoGebra software. All right, yes. So as we did in the previous lesson, let's make here blank. Okay, so we can clear the two lines. Okay, yes, then we make here blank like that. So this will be our working sheet. Okay, this will be our worksheet. Okay, yeah, so let's quickly go to where we take our circle as we did in the previous video. Okay, so we click on this and then select circle with center through point. Okay, so once you click on that, you come to your worksheet, you click wherever, any place, then you drag it to create the circle. Okay, yes, once you create the circle, then you release it to any size you like. Okay, yes, so this is our circle. So once the circle is created, you realize that we have the center as A, and then we have another point labeled as B, and the C there, that is the circle. Okay, yes, okay, so this one, because we are dealing with what we are saying, the angle is extended by a diameter, we are going to draw our diameter. So we come back to where we selected line segment in a previous video, but in this case we are not going to select what a line segment, we are instead going to use a line. Okay, yes, so once we click on a line, we come to the, can start from here, the center, click on it and then move like this. You see that a line has been created. Okay, then we can click here to make a point here so that we have C there. Okay, so we have this line. Now we want to get the diameter. We want to clear the line outside the circle. So what we'll do is we'll come back to where we selected the line again. Then this time we choose line segment. Okay, choose line segment. Then we come here at this point. Okay, we make a point here. Then we move on, yes, to C. Okay, then we make the point there. Good. Once we make the point there, then we come here and then take the line where the line is, because that is where we drew the line. We take it so that outside it will clear. So we realize that the line is gone now. So once we have this one, then we can come back and draw another chord like we did in our previous lesson. Then we make it another one here. Okay, then we click here again and then we drag down. Okay, we make another line segment to join like this. Now we have this triangle drawn in the circle. Okay, so we are going to get our angle, whether indeed it will be 90 degrees. So once you do this one, then you go to where we have the circle and the angle. So we are going to choose what angle. We click on that, then we select angle. So we are going to do it clockwise, anti-clockwise direction as we did in the previous lesson. So we click here first, then we move to point E, we click there, then we come down, then we click on where C is. So you see, now we have gotten our 90 degrees. So it is very obvious, it is very okay. Yes, so you realize that it is proven, and indeed it is true. So we have gotten a 90 degrees. Have we gotten that? Yes, very, very easy. So once you have this GeoGebra, it will always help you to know. Okay, let's try and bring it here. Okay, so let me drag it here to this point. So you realize that even if I bring it here, it is still 90 degrees. It doesn't change. Okay, let me try and draw another one and see if I will get that. Okay, so I will pick line segment again, then I will draw one here. Yes, then I will draw another one also here. Good. Yes. Yes, so then we go to we pick our angle. Okay, then we come here, click here, then move anti-clockwise direction, then we come here. Good. And you see that that one also gives what, 90 degrees. So wherever you see the angle is, once you realize that that angle is subtended by the diameter, then know that it is always going to be what? Right angle or 90 degrees. This is very, very basic. Let me try and draw another one downwards. So I'll come back. I'll select my line segments. Yes, so I have one here. Have one here. Then I have another one here, like this. Okay. Then let me take my angle. Yes. Take my angle. So I'll click here, move here, and then move here. Good. So you see that that one is also 90 degrees. So this one is very, very easy, no matter how you want to get your shape. Okay, yes. So that is what this theorem. If that's the case, then let's end here and continue next time. So in our next video, we are going to look at the rest of the theorem. My name is Evans. This is Maths TV. I'm still your mathematics facilitator. Kindly go to YouTube and then search Maths TV. Don't forget to subscribe, like, and share the videos as well. You can also get Maths TV on TikTok. So if that's the case, then we end here. See you next time. Bye bye.